now we can start. And I hope everyone is at par as per the work that we did last time.
Yeah.
Because like I said, still we are supposed to look at the R fundamentals before we do anything related to data cleaning, data visualization, and also data analysis. We need to understand the basic R functions and syntax. And I just want to do a recap of what we did in the last session. I remember we looked at how we can execute R commands, and we looked at how we can get help in R. Don't forget this one. We looked at also how we can access R inbuilt datasets. Don't forget that one. Then after that, we looked at variables and objects. We looked at how we can create variables here. I remember we looked at how we can create variables. Then we looked at how we can display variables in these three formats, either using this format, using this format for print, or using cat. Also, don't forget that one. Then also I showed you that some of the naming rules in R, whereby the rule number 1, I told you that names can contain letters, numbers, underscores, periods. Rule number 2, it was names cannot begin with a number. Rule number 3, it's that names cannot contain spaces. Another one is names are case sensitive. You cannot create a variable using small letters and decide to print it using capital letters. That one will not work. Then of course another thing is avoid using reserved words. So those are some of the naming rules that we looked at. And I gave some of the valid variable names that you can write in R here. Then also I talked about comments. I said that comments you use hash. Then after that I talked about data types. I told you that in R we have different data type. Like every object in R has a data type, and I talked about numeric. I talked about integer. I talked about character. I also talked about logical data type. So under that I talked about data types. Also don't forget about data type. Every data that you'll be collecting in the field, all the columns have data types. So don't forget about that one. Then I also talked about operators in R. Remember I told you that we have around four types of operators in R. I talked of arithmetic operations. Those are addition, subtraction, multiplication. I also talked of relational operators. These are greater than, less than, equal to, not equal to, and those ones. Then we have another one called logical operators. This one you only have two, the AND, then also OR. Don't forget to look at that one also. Then I also talked about assignment operators, and I told you that we have two assignment operators. It says you can use an equal sign, or you can use this function. They all perform the same thing. Then after that, we looked at data structures, and I told you that we have 5 types of data structures. I told you that we have vectors, we have matrices, we have lists, we have arrays, and then also we have data frames. And what I remember last time we covered vectors, and I told you that we have 2 types of vectors. I told you that we have numeric vectors and also character vectors. And also I showed you how we can do basic vector functions. I showed you how we can do basic vector indexing, and I told you that indexing is just subsetting. Then after that, the last thing that we looked at, it was matrices, whereby I told you that matrices, these are just 2-dimensional data structures. And also I told you that in a matrix, all elements must have the same data type. And I showed you how we can create a matrix in R using the function matrix. Then you can highlight the numbers in the matrix, then the number of rows and the number of columns. For example, let me just run this one. Then I can print it. You can see this is a matrix containing the number of rows and also the number of columns and the values inside. So I showed you how you can use the colon, or you can decide to highlight those numbers using concatenate, then define your matrix like this one. When I run this one, you can see that still it will produce a matrix. Yeah, so that is what we covered the last time. Hope everybody's at par with that before we proceed, because
yeah, it is clear.
yes, now
Let that proceed, yeah.
let's proceed. So we'll still I'll proceed with the data structures. Last time we covered the vectors and also we covered the matrix. But we just covered how to create a matrix. I want to show you how we can do some matrix basic operations. So I want to show you what we call matrix dimensions. How can we check matrix dimensions? That is what I want to show you the next. So assume you have this matrix, like this is a matrix, and you want to see the dimensions of this matrix. This is how to do it. You say that you write dim, you just write dimensions, this function dim, then you mention your matrix. For example, matrix 2. For example, matrix 2, like this. Then it will give us that this is a 3 by 3 matrix. Or, in case you just want the number of rows, you just write n row. You write n row, then you mention matrix. For example, this one, matrix 2. Notice that it is giving us 3. The number of rows in matrix 2 is 3, and you can count it. We have 1, 2, 3. In case you want to do the number of columns, you just write n col, like that. N col, then you write that matrix. Matrix 2. So that is how to do matrix dimensions. Hope that is clear on your end.
Yeah, it's clear.
Yes, let's proceed. I want next to show you what we call matrix operations. Just like we did vector operations, let's also do matrix operations. And for example, the first operation that I want us to see is adding a certain number to a matrix. For example, you have, let's say you have this matrix 2, and you want to add a number like 5 to it. I want to show you how we can do it. For example, let's say I want to add 5 to matrix 2. What I'll do, I'll just write matrix 2 like that. Then I just add 5. Yes, I just add 5 like that one. Then I run. You see right now, in the matrix 2, this was matrix 2. Like for example, 23. When you look at the final answer here, I've added 5, now it is 28. Look at this one, it was 12. When I add 5, 17. Look at this one, it was 43. When I add 5, it's 48. Hope that one is clear. Adding a number to a matrix.
Clear.
Yeah, this is now how you can add a number to a matrix. For example, let's add, for matrix 1, let's add, for example, 7. Just write matrix 1 plus 7. Then you run it. It will give you the answer. You can see that right now, this is now the answer. And when you look at matrix 1, let me just run matrix 1. You see like this one. When you add 7, this one will be 8, like this. When you add 2 here, this one will be 9. When you add 7 here, this one will be 12. Sorry, it will be 11. When you add 7 here, it will be 12. When you add 7 here, it will be 13. So that is how to do matrix addition. The next thing is multiplying a matrix by a number. How can you multiply a matrix by a number? For example, let's say we have matrix 2 or matrix 1, and you want to multiply it by a number. Just use the multiplication function, then you put that number. Like matrix 1 times 3. Then it is going to multiply all the numbers in the matrix. You can see everything is now multiplied. This one was 1, but when I multiply by 3, I get 3. 2 by 3, I get 6. 3 by 3, I get 9. 4 by 3, I get 12. Hope that one is clear.
Yeah, it's clear.
Another thing is subtracting a number from a matrix. Subtraction. I want to subtract, for example, let's say matrix 2 I want to subtract like 2 from matrix 2. So I just write matrix 2, then I subtract that particular number like 2. That is how to subtract a number from a matrix. And you'll see, right now, the matrix 2 has been subtracted. From each number, the 2 has been eliminated from each number. Is that clear? This is just a straightforward.
Yeah.
Then another thing that so that is how to do matrix operations. For example, you can decide to divide. Also, let's try to divide. For example, I want to pick a matrix like, let's pick matrix, let's see, let me print this matrix 2. Let's divide the matrix 2 with something like 2. We'll just write matrix 2, then divide matrix 2. You see? That is how to divide. So this is what we call matrix operations. Teacher, can we proceed?
Yeah. Yeah.
Okay, let's proceed. Another thing is transposing a matrix, what we call matrix transpose. It's also very important. Matrix transpose. Transposing is changing the number of rows to columns, then columns to rows. It's like you are interchanging. That is what we call transpose. And in case you want to do transpose, you just write T. T into bracket, then you mention your matrix. For example, let's do matrix 2. Let's transpose matrix 2. Like that. When we transpose matrix 2 was, this was matrix 2. 23, here it's 23. You see that right now, under the original matrix 2, 12 was in this particular section, but right now when you look at this transpose, you can notice that now 12 it is on the row. When you look at the original, like in this 43, it was on column number 3. But now under the transpose, you notice that it is on row number 3. Hope you get the point. Like transposing is like interchanging values from columns to rows and from rows to columns.
Yeah, it's clear.
Yes. Let's also transpose matrix 1. Matrix 1. It's like you are interchanging columns to be rows, then rows to be columns. And this one is very important when we'll be looking in data cleaning. There is something that we call wide data, and then also pivot long and pivot wide, whereby you change from a wide format to a long format. That one I'll show you under data cleaning. You can see this one also, it has now changed. The rows have been converted to columns, then columns have changed to rows. So that is what we call matrix transpose. Let's proceed. I want to show what we call another thing called matrix indexing, just like we did vector indexing. And indexing, I told you that this is just subsetting or extracting values from a matrix. Extracting. From a matrix or subsetting. That is what we call matrix indexing. And for example, I want to give you an example. For example, we want to pick a value that is on column number 2 and also row number 3. Column number 2, then row number 3. Let's for example, I just want to run that matrix 2 so that you see it fast. Column number 2, this is matrix this is matrix 2. So I want you to tell me the value that is on column number 2, row number 3. Which number is that? Column number 2, row number 3.
That one is 90 or
Yes.
89.
90. Because when you look at the row number 3, it is here. Then column number 2, the value is 90.
90, yeah.
Yeah, so we want to extract that one by what we call indexing. So what you do, just write a matrix. Just write matrix 2. Then you open square brackets. Then you define the column number, the row number, number 3. Then you define you define the column number 2, like that. So it is extracting the value in column number 2. It is going to extract the value from row number 2, from row number 3, then column number 2. Then we run it. You can see it is 90. Let's also extract. I want you to tell me the value from row number 2, then column number 3. What is that value?
That is 67.
67. Also, let's do that one. So just write matrix 2, then square bracket, then we specify row number 2, column number 3, like that. You see it is 67. Then of course, in case we just want to extract like the whole, for example, let's say we want to extract the whole row. Like for example, you are only interested in extracting the row number 2, this is how to do it. We just write matrix 2. Then you open square brackets, then you define only the row number 2, comma, but you don't specify the column. That one you'll be extracting only the row, and I'll run it. And as you can see, it is 32, 24, 67. So this one has only extracted the values in row number 2. Then, for example, let's say we want to extract values from column number 3. This is how to do it. I just write matrix, then square brackets. Then because I don't want to specify the number of rows, I will not put anything. I just add a comma, then I specify the column number 3. Just like the way it is specified here. That is how to extract it. Then I run it. Then it will give me the, let me see.
You did not put 2, matrix 2.
Oh, sorry.
You just write matrix, yeah.
Yes, yeah. Like that. You see, this is now the values in the column number 3. So you hope you all are now understanding what we call indexing.
Yeah.
So that is what we call matrix indexing. Yeah, I'll not go much into matrices. At least we have looked at matrix indexing. We have looked at how to transpose a matrix. And we have looked at how to do matrix operations and also matrix dimensions. And of course, I taught you how we can create a matrix like that. So that is all about matrices. Hope that one is clear, or in case you have any question before we proceed to data frames or arrays.
Yeah, it's clear.
Yeah, on our side it's clear. You can continue.
Let's proceed. So like I told you, under the data structures of vectors, we have matrices, we have lists, we have data frames, and then we have arrays. So the next thing that I want us to look at is the lists. Lists. That is the third data structure that I want us to look at. So remember something that I taught you under the vectors. I told you that a vector just records or stores multiple values that are of the same data type. That is the concept of a vector. It stores the values, the multiple values of the same data type. If there are numbers, they should be numbers. You don't have to mix. But a list stores both numbers and also characters. So a list stores values, multiple values that are of different data types. That is the concept. So let me just say that a list can store different data types together. Then in case you have a question, you ask, because I like going fast and I can leave you behind. So like I said, a list just stores different. They store values. They store multiple values that can be of different data types. That is what I mean by a list. For example, you can store age, then you can also store gender. You can also store, for example, name, like that. Unlike the vector, whereby a vector you cannot store in a vector both age and also both gender, because one will be a character, the other one will be a number. But in a list, you can store those different types of data types. And I want to show you how we can create a list. For example, to create the information of about a student, let me just call it student, then I'll show you. The function for creating a list, it is just called list. So in this list, sorry, let me remove this Y. In this list, I want us to store the name of the student. Name is equals to, let me say, Lick. That is the name of the student. You can see that that is a character data type. I want also to store the age of the student. Let's say 43. That is the age of the student. I want also to store the height of the student. Let's say height is 1.75. That is it. Then I want us also to store if the student passed or not. So I'll say passed is equals to, then I'll just true. True meaning the student passed. Then I'll store, for example, the scores. The scores. Let me store something like scores or the marks. And I want to store scores like 70, 80, 90. Let me just store. In case you have multiple numbers, you always use concatenate 70, 80, then 90. So this is what we call a list. And I want to draw you to this one. I told you that list can store different data types all together. As you can see from this list, I have stored the name. You can see the name. Name is a character. But when you look at the age is numeric. Height is numeric. Past, as you can see, this is logical. So a list can store different data types. For example, let me just start like gender. Let me say gender is equals to male. Like that. Then I run it. Just expand this. So this is what we call a list. It can store multiple values of different data types. Then after creating it, then I can just print it. Student. You can see this now a list. You can see that this list contains the name, the age, the gender, the height, the past, then also some of the scores. Yes. So that is what we call a list. Is that clear on your end? That is what we call a list.
Yeah, it's clear.
Yes. So a list is just the vice versa of a vector. While a vector is storing values that are of the same data type, a list is storing multiple values that are of different data type. So it is not necessary that a list should store values of different data types. Also, it can also store values of the same data type. As you can see, it can store age, it can store height, it can store scores, but also it can also store the different data types like these ones. Logical, you can see character. Yes, so that is what we call a list. And under list, I want to show you some of the things. The first thing that I want to show you is the structure of a list. Structure of a list. A list contains structure. And in case you want to understand the structure of a list, you just write STR. STR meaning structure. Then you mention the list, that is the student. It was called student, yes, like this. Then you run it. You see? This is now what we call the structure of a list. You can see that it is saying that this is a list of six values, and the first name is the first object is name, and you can see it is saying that the data type is character CHR, and you can see that the name is Lick. You can look at the age. The data type is numeric NUM numeric, and that is the age. You can see gender. Gender, the data type is CHR, that means character. You can see height. Height data type is numeric. Then you can see past. Past data type is always logical. True or false, those are logical data types. Then we have scores. Scores we have 70, 80, 90. Data type is numbers. Yes. Is that clear?
Yeah, it's clear.
Yes. Let's proceed. That is the structure of our list. And you need to understand that structure because anytime you have your data in R, the first thing after importing the data, the first thing that you do is always to assess the structure of the data, and we'll be using this function. So don't forget about that function. We'll be handling it when we'll be working with real data sets.
Can you go up a little bit on the list? Let me see something.
Yeah.
I think I'm missing something here.
Yeah.
Oh, okay. I'm missing the agenda. Okay, fine. Okay,
Agenda.
thank you.
So that is our list. I want also to show you how to access list elements. Accessing list elements. This is very key, especially when you want to access the columns in a data set. This is how we'll be doing it. For example, in case you want to access the name of the student, you just write the object that is the list, the student. Then you write $, then you specify the name like that. Then it will give you the name of the student. Is that clear? How to access list elements? You write the name of the list, then $, that particular column that is inside the list. For example, this one is name. So this is the object of the list, then $, whatever is inside that you want to see. For example, I want to see the age of the student. I'll just write student, which is my object, student, then $, then I just write age. Then I run it. It is going to give me the age of the student. Let's say I want the gender of the student. I just write student like that, then $, then I specify that I want gender. Then I run it. Hope you can see my output.
Yeah.
Yeah, so that is how we can access list elements. This is similar to a real data set. This is how we'll be accessing the values in a data set. You just mention the name of the data set, then $, the column in the data set. Then you'll get the values in that particular column. Yes, don't forget about how to access list elements. It's very similar to accessing values in a data set.
Yes. Hello.
Any question?
Yes, I have a question.
Yes, you can ask.
Yeah. In accessing the list, it means that if I put the $, there's no interest, right?
Pardon, please, you are speaking at a low voice. I can't.
Like, if I want to access the list element,
Yes.
I write the student name and I put the $, without space
Exactly.
in between.
Exactly. You just write the
Okay.
student. Remember, the student is now the list that we created here. Then $, that particular column or that particular variable that we specified in this particular list. That is
All
how
right.
to do it. It is similar to accessing values in a column in a data set. You just mention the name of the data set, then $, that particular column in that particular data set. Then you'll be able to get the values in that particular column. Hope that one is clear.
Yeah.
Yes. So when we'll be working with real data sets, when I do $, hope you will be understanding that that is how to access some of the observations in a column. We proceed, right? Or any question? Any other question?
We proceed.
Yes, we proceed. Adding elements in a list. And I want you to take this list as a data set, because when we'll be working with the real data sets, this is how we'll be doing it. So a list is like a data set. So I want to do adding elements in a list. So in your mind, just know like it is similar to adding elements in a data set or adding columns in a data set. Let's say for example, this is now the list that we have. This list, you can see it is called student. And it contains some of the columns like name, age, gender, height, past, and scores. Let's say you want to add another element in this list. For example, let's say country. You want to add a country, the country from which the student comes from. What you do, you just write what you do, just write, you just come to write the student like this, student. That is the list that I have already created. Then I just $sign by the new column that I want to add. For example, I just want to add country. That is how to do it. I just write country. Let me use county. I just write county. Then I specify the county. For example, I'm going to specify the county. For example, you can call a county like Bungoma. So that is how you can add an element in a list. When I run it, it has run. Now let's print again that student. You'll see that an element called county has been added to the list. Can you locate it now? County, Bungoma. That is how to add an element in a list. You just write the object, that is the object, then $sign, the new element that you want to add, and you specify what is the name of that particular element. Then it will be added. It will be added. Similar to a data set. In case you want to add a new column in a data set, this is how we'll be doing it. Is that clear?
Very clear.
Yeah.
Yes. So that is how to add elements in a list. Let's add another element. I just want us to add another element so that we understand it better. Let's add another element. Let's say I want us to add another element. Let's say I add an element like school, the school of the student. Just write like that. Then in quotes, I just mention the school. Let me mention a school like Alliance. That is how to add an element. When I run it, and I come here to print the list again, you notice that the school will be added. You see now, we have a new element called school that has been added in the list. So that is how to add elements in a list. And in a real world situation, that is how to add a column in a data set, a new column in a data set. Don't forget about that one. It's very key. Another thing, it's removing elements in a list. Removing elements in a list. Remember I told you that when we handle lists, at the back of your mind, just know we are handling data sets. And when I say removing elements from a list, it's like I'm saying removing columns from a data set. So for example, let's say you want to eliminate an element like height. Let's say you want to eliminate an element like height from this particular list. Let's remove height. Let's remove height. You just mention the list, that is the student. Just mention the list, the student, like this. Then $sign that particular column that you want to eliminate. Let's say height. Then we equate it to null. Null, like this one. That is how to remove elements from a list. Then I run it. After running it, let me print it so that you can see that the height will be eliminated. Can you see it? Can you see now? There is no height. It has been eliminated. There is no height. Let's also eliminate scores. Let's also eliminate scores. So just write scores. None. Then after that, I can just print the list. You can see that now, right now, height and also scores have been eliminated. Hope that one is clear on your end. That is how to remove elements in a list. Is that clear?
Yes.
Yes. The name of the, let me use in a real, the name of the data set, $sign, the column. Then we equate it to null. Then it will eliminate that particular column. And in a real world situation, it is, you go to collect data, And when you come to analyze, you notice that some of the columns are not important. So in case you want to eliminate those unimportant columns, this is how you do it. Don't forget about in a real world situation. Let's proceed.
Okay.
Let's proceed. So generally, that is all about lists. And lists reflect data sets. Don't forget about it. How to add elements in a list is similar to how to add columns in a data set. How to remove elements from a list is similar to how to remove columns in a data set. How to access list elements is similar to how to access data set columns. How to assess the structure of the list is similar to how to assess the structure of a data set. And yeah, that is it. So don't forget about lists. It's very key. Its concept, it's very key. Let's go to the next one. The next one is what we call data frames now. Data frames. Before we go to data frame, any question on the list? Any question on the lists?
I think it's clear.
Lick, any question about lists?
No, I'm okay.
All right, let's proceed to data frames.
Yeah.
So I was saying that all those operations that we have been performing in a list, they are similar to those operations that we perform in a data set. But I never mentioned that a list is a data set. Don't ever confuse that one. A data set is like a data frame because it comes in a data frame format. So when I talk about data frames, this is just data sets. This is just like a data set. So, like I said, another thing, a data frame is the most commonly used data structure for storing data sets. A data frame. All data, in most cases, all data sets that you go to collect or all data that you go to collect in the field, that data is stored in a structure called data frame. That format that contains the columns and also contains the rows. That is what we call a data frame. Each column, it usually represents a variable. In a data set, we have what we call a variable. So each column is always representing a variable. Then each row is always representing an observation. So the first thing, I can say that this is a data structure that stores data sets. Data structure for storing data sets. That is what we call a data frame. And I told you that each column represents a variable. Represents a variable. I also told you that each row represents an observation. Don't forget that one. That is now real world data sets, how they behave. A real world data set, it is stored in a structure called data frame. And each column in that structure represents a variable. And each row in that structure represents an observation. Hope that one is clear before we see how we can create a data frame. And also how we can.
Yeah, it's clear.
Yes. Now, I want us to create a data frame. Any question? Link? You have a question?
Yes. Can you repeat a little bit because my internet is on and off?
Okay, so I said that a data frame is a data structure for storing data sets. Hope you understand what is a data set.
Yes.
So, and I talked that in a data frame we have columns and rows. And I said that each column usually represents a variable, and each row represents an observation. I think you have background noise. Is that one clear? I said that a data frame is a data structure that stores is a data structure for storing data sets. And I say that it contains columns and rows. And I also say that each column represents a variable. And I say that each row represents an observation. Is that clear? Is that clear? Or still the internet?
I think his internet is slow.
Link, are you available? Yeah, so hope William you understand what a data frame is.
Yeah, it's clear.
Yes, it's a structure for storing data sets, always containing columns and rows. In a data set, a column, we don't call it column, we call it a variable. And each row, we usually call it an observation. So that is what we call a data frame. So I want to show you how we can create a data frame.
Yeah, let's proceed.
So a data frame in most cases contains vectors. Vectors, you can see that we may have a column for age, ID, name, and so on. So I want to see how we can create a data frame. Creating a data frame is what we call data entry in R. If someone tells you to do data entry, it means that he wants you to create a data frame for his data. Creating a data frame. And I want to create a data frame and I want to call it students. I just want to call a data frame students. The function for creating a data frame, it is called data.frame. Data.frame. And in this data frame, I want us to have the first column called ID. And so, like I said, in a data frame, the columns are like vectors. So when I want to write a vector, I told you that we use concatenate. So ID is equals to concatenate. Then let me pick randomly 1 to 5. 1, comma, 2, comma, 3, comma, 4, comma, 5, comma. That is the first column that I want to add. And like I said, columns behave like vectors in a data frame. That is why, because you can see that ID is just a vector. Then let's proceed. Let's add a column like name. So we just write name as a vector. So I write name is equals to, of course, concatenate, like that. Concatenate into brackets, then I put the names in quotes. For example, let me write John. John. Let me also write Mary. Mary. Let me also write Peter. Let me also write Faith. Faith. Let me also write Brian. So that is another rule that I want to tell you about a data frame. All columns that you specify, they should have the same number of observation. If the ID contains 5 observations, 1, 2, 3, 4, 5, name should also contain 5 observations. John, Mary, Peter, Faith, and Brian. These are 5. Let's add another column like age. Age is equals to concatenate. And like I told you, these columns are like vectors. There is no change. There is no difference between a column in a data frame and a vector. 21, 20, let's say 34, 56, 54, 5. Then I want us to add another column, gender. I want us to add a column like gender. Gender is equals to concatenate. Then I start. What is the gender for John? I want to good to be
It's male. It's male.
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 Yep.
What is the gender for Mary?
Female.
Female. What is the gender for Peter? Male.
Male.
What is the gender for Faith? Female.
Female.
Then the gender for Brian?
Male.
Male. Yeah, so that is how to do it for gender. Then let me add the last one. Like I told you, these are just vectors. These are vectors, and they are columns in a data frame. So columns in a data frame, they are vectors. You write them as vectors. Then data frame will combine those vectors to form a data frame. Let's add their marks. Because they are students, let's add their marks. Marks is equals to concatenate into bracket. Into bracket, let me mention the marks for John. John scored 67. Mary scored 76. Peter scored 89. Faith scored 34. Then Brian scored 47. That is it. So hopefully you are back. I want to repeat to you about our data frames.
Yes, I'm back.
I was telling you that a data frame is a data structure that stores data sets. And I told you that a data frame contains columns and rows. And I told you that each column in a data frame represents a variable. And I also say that each row in a data frame represents a variable. Sorry, it represents an observation. Sorry for that. It represents an observation. And I was asking you the question, do you know what is a data set?
Yeah.
Yes.
Data set, yes.
Yeah, so a data set is just a data structure that is storing your data that you have collected. And it is always in a data frame format. And a data set usually contains columns and rows. Those columns in a data set, they are called variables. And those rows, they are called observations. And now here is where I'm showing you how we can create a data frame. And I told you that creating a data frame is what people call data entry in R. There is no any other data entry apart from this. This is how to do data entry in R. For example, I wanted to create a data frame called students using this function called data.frame. And I said that I want an ID in my data frame. So I specified an ID of numbers from 1 to 5 randomly. And I said,
yes,
in each column in a data frame, these are just vectors. As you can see the format, they are just vectors. So I specified the name. Names of those 5. I specified their ages. I specified their gender. Then I also specified their marks.
Their marks.
Then there is another consideration that I told you. I told you that in a data frame, all vectors or all these columns, they should have the same number of observations. If ID has 5 observations, it means also name should have 5 observations. So that for them to align, all of them should have the same number of observations. Hope that one is clear.
Yes. Yeah, it's clear.
Yeah, now let's run it. After running it, I want us to view it by just writing students. This one. Can you see now the data frame? Containing ID, containing name, containing age, containing gender, then it contains marks. So these are what we call columns in a data frame. And in a data set, we usually call them variables. And these ones are what we call rows. These ones, they are rows. In a data set, we usually call them observations or the responses from the participants, these ones. So generally, that is what we call a data frame or a data set. A data set is always in this format. So that is how to create a data frame in R. Don't forget about it. In case you'll need to do data entry in R, that is how you'll be doing it. I want us to see how we can explore a data structure. Exploring a data structure. Exploring a data structure is like exploring a data set. So when you have your data in R, this is how you can exploit. The first thing is to check for the structure of the data set. I told you that structure, we usually use str. Just write structure, then you mention the name of the data set or the name of the data frame, students. Then we run it. Then you'll be able to see the structure. The first thing it is a data frame. It contains 5 observations. Then it also contains 5 variables. And one of the variables, you can see that it is an ID. And you can see that the ID, the data type is numeric. Then these are some of the observations in that ID. Then we have name. Name here, then the data type, it is character, CHR. Then these are some of the observations. Then we have age. The data type is numeric. Then these are some of the observations. Then we have gender. Data type is character. Then these are some of the observations. Then we have marks. Marks is numeric. Then these are some of the observations. Hope you are understanding that one.
Yeah.
Yeah, it's clear.
The structure of a data frame. Let me just write here. That is the structure of a data frame. Another thing is what we call the summary statistics of a data frame. You just write summary, then you write students. This is going to generate descriptive statistics for the data frame. And as you can see, I've just written summary. Summary, then I have put in the bracket the students. And look at the output. Look at, for example, the ID. It has picked the first variable, the ID. It has given us the minimum value, the first quartile, the median, the mean, the third quartile, the maximum value. Then look at name. Remember, name is a character. We cannot do the mean, median of characters. So it has given us the length of that character is 5. The number of unique levels in that character is 5. The number of blanks, it is 0. We don't have any missing value in that name. Then the minimum
Number of character.
the minimum number of characters is 4. The maximum number of characters is 5. You can see, so for the numeric, you can notice that it gives us the statistics. Those are the measures of central tendency. Then for the character variables, it gives us the distributions, the frequency distributions and the unique values. So that is how to do the summary statistics of a data frame. Hope that one is clear.
Yeah, it's clear.
Another thing that I want to show is in case you want to view.
Yeah, yes, we can continue.
In case you want to view the few observations of a data frame, you use a function called head. I just write head, then I specify the data frame. It's called students. By default, it usually displays the first 6 observations of the data by default. Then another one is called tail. Tail displays the last 6. So I just write tail, then students. These ones I'll show it mostly when we'll be dealing with real-world data sets. Head displays the first 5 observations of the data. Then tail displays the last 5 observations of the data. Yeah. So just grab that one when we'll be working with real data sets. That is how we'll be doing it. Is that clear?
Yes.
Another thing that I want to show is the dimensions of our data frame. Just like I showed you how we can do the dimensions of a list, it is similar to dimensions of a data frame. The function, it is dimension. Then you mention the data. Students. It will give us the number of rows and the number of columns. As you can see, it is saying that we have 5 rows, then also we have 5 columns. In case you just want to be specific to the number of rows, you just write end row, then you specify the name of the data. Then it will give you 5. In case you want to be specific to the number of columns, you just write end col, then students. Then it will give you the number of columns. Hope that one is clear. It is similar to lists.
Yeah.
Yes, let's proceed. In case you want to check the column names for your data frame, you want to be specific and only check the column names of your data frame, this is how you can do it. You just write names into bracket, then the name of the data frame, like that. You can see it has highlighted the names in that particular data frame. Oh, sorry, it was students. Sorry, it was students, not students. Student was a list. Now I want to do the data frame. You can see this now, how to check the column names. In case you don't want to use names, you can use call names. They perform the same function. Students, like that. Is that clear?
Yes.
Another thing, accessing columns in a data frame. Columns in a data frame. Just like I've showed you how to access elements in a list, is similar to how to access columns in a data frame. For example, you want to access a column like marks. You just specify the name of the data frame, that is students, then $sign, that particular column that you want to access. Then you just run it. Then it will give us the output. You can see the output. For example, we want to access the names of the students. We just write the name of the data frame, then $sign, that column representing name, like that. Then you run it. Then it will give us the names of the students. So that is how to access columns in a data frame. It is similar to accessing elements in a list. Is that clear?
Yeah, it's clear.
Another thing is how to eliminate columns in a data frame. It is similar to eliminating elements in a list. For example, let's say we have our data frame called students. It contains ID, name, age, gender, and marks. And let's say we are not interested with age. We want to eliminate it. You just write the name of the data frame, that is students. Then $sign, that column that you want to eliminate, let's say age, is equals to null, like I've just told you in a list. That is how to eliminate columns in a data frame. When I come to print again students, you notice that age will be eliminated. You see, we don't have age. It has been eliminated. Is that one clear?
Yeah.
Yes. So generally that is all about a data frame. We'll learn more when we'll be handling real data sets, because all the analysis will be dealing with data frames. So we'll handle more about it when we'll be handling real data sets. Today just wanted to show some basics. You need to understand some of these basic functions before you do any analysis. So that is all about data frame. I'll give you certain assignments that you'll try so that you understand it more better. So generally, those are the four main data structures that you need to understand. You need to understand a vector, because in any data set that you'll be collecting, those column names, when you look at their format, they are just vectors. Another thing is lists. The properties of a list, most of the properties of a list, they are similar to properties of real-world data sets. Then another thing that we looked at is now what we call a matrix. A matrix, we also looked at it. Then the last thing that you have looked at is what we call data frames. Data frames in real-world situation, they are called data sets. So those are the four main data structures that you need to understand in these R fundamentals before we proceed to any other. So for the data structures we have finished. I just want us to draw you to the last thing. Then after that we'll be done with the R fundamentals so that you can proceed to the main things that you are supposed to learn. I want to draw you to any other thing. In case you have any question about a data frame, any question about a data structure that you haven't understood.
That's clear.
I see it seems Leak has left.
Yeah. I think his network is not stable.
The internet.
Yeah.
Yeah, but we have covered a lot. We have covered a lot. I think we can just stop there. We'll finish tomorrow for the R fundamentals, then we can proceed to data cleaning and transformation, working
Yeah,
with real
that's
world data sets.
because now I think we only left with arrays. Arrays and then conditional statement, loops, function. Yeah, I think
That one I'll show you tomorrow then.
yeah, it's okay.
Yeah. So
So that you
I'll share
so that you share the record with them, then you will not miss.
yeah, I'll just save this recording. I'll share with you plus the materials plus the scripts.
Mm.
All right. Let's meet tomorrow.
Thank you.
All right.